On three, two, one. Hello, everyone. Welcome to Me versus AI for February 2021 session. Today, again, we have a fantastic panel. We have Martin Berdes. Welcome, Martin. Please introduce yourself.
Hi, yes, I'm an AI enthusiast, of course, data scientist, and definitely worshipper of control engineering and complicated AI solutions like transformers with image recognition and NLP applications
Where you
today.
stay right now, Martin?
Sorry?
Where you stay?
In Gdańsk, yeah, in Gdańsk, just in the north of Poland, where the Solidarity movement was born, 1989. So it's still quite cold, but in plus at the moment. So I'm keeping busy and obviously focusing on some transformer literature and discussions. So yeah, very happy to be here, and thank you, Guy, for your invitation
Thank you,
tonight.
Martin. I'm happy. Also, we have Dr. Tom Ives. Tom, small words to us.
Do you want me to give a intro, basically?
No, your intro. It's whatever you want to say about.
Oh, sure. Just a long-time predictive analytical geek. Fell in love with it even in undergrad to do predictive analytics. Started more in the physics realm, the engineering realm of that. As all engineers that do a lot of modeling know, it's all ground in empirical work, which is yet another term for data science. And but dabbled in design of experiments and control system design like Martin. Was very excited and thrilled to do my PhD on design and modeling of hybrid electric vehicle power plants. And while I was doing those studies, was introduced to what we now call data science and deep learning by learning neural networks and such. And then over the years, it was just very obvious that data visualization, data mining, data processing, predictive modeling with just data became more and more important. So I've just followed that transition in my predictive analytics career.
Thanks, Tom. For sure, this session, once again, it comes with the co-host and cooperation with Ammar Mohanna. Ammar, he's with us and he will show to the camera soon. And also, there is one guest is missing, is Mr. Dennis Rothman. In fact, because of special case that he is facing, so we record with him from yesterday. And right now we will start with this records. The idea of this session, it's about history of ideas, how everything is integrated and developed over the history to reach this point that we are right now. And we started from Dennis Rothman by yesterday. I will try right now to broadcast the records with him, and then we will start discussion with Martin and Tom, because we will start with Dennis, because if there is any comment from our guest and or from who's, let's say, following us on YouTube, he is able to comment and ask his question. By the way, there is a message from Dennis Rothman. For any question, he is able to answer you on LinkedIn anytime. This is message from his side. I have to tell you all. I will share my screen right now to check on the records. Okay. Hello, everyone. I hope that the sound is clear. It will be recorded. For special cases of Mr. Dennis. So today we have Mr. Dennis Rothman with us. Dennis, please introduce yourself and tell us about your latest project or product, what we have on the pipeline right now.
Well, so I'm Dennis Rothman, and right now I'm working on the theory of complexity. I've been working on this for decades, in fact. So, because I worked a lot in the supply chain, where you have, if we take like COVID, for example, you can see that it's a vast supply chain that goes from getting the ingredients to make a vaccine, but even before that, developing the vaccine. On the other side, having trucks with refrigerating systems and having warehouses, doctors. So you can see that if you take all the actors in there and the governments and people talking, you put all that together, you get something extremely complex. And to make that balance, to make it work together, it can go from a few weeks to maybe a year to get it all working together in sync. So I worked a lot on complexity like this for laboratories. I worked a lot for warehouses. I worked a lot for e-business, and now I'm putting it together in one model. I actually got it to work in the middle of 2020. Now I'm just fine-tuning. So I have this big AI model of complexity, which involves non-AI algorithms as well.
Is it like a unification of the terms and the methods used in the different sectors, or you are like not giving a new method?
So it's just a continuation of a model I wrote in 1997, which is already a model that can manage complexity in any field. It's a mathematical model. And it's something I developed in 1997 in data sets and an algorithm, and it's still running today. It's one of the oldest algorithms in my mind that are still running in big corporations, not small companies. I'm talking about multinationals. But this time I wanted something even more abstract that would include human reactions, human interactions, the way people react to a subject, because you can have your supply getting there on time, for example, a vaccine, but then you can have the European Commission saying, well, let's make sure it works first. So that's a human factor, goes back to a legal. So I'm including more factors in it.
Now, this is lead me to that question right now. Dennis, we are talking about mathematical model or kind of, let's say, workflow with mathematical model, because what you are explaining with all of these factors, maybe it comes with one result, but how to model it, it's okay. Something I want to have more explanation. Maybe it's out of our scope, but yes.
No, it's in your scope, because to implement artificial intelligence, most people think implementing artificial intelligence, oh, I download an algorithm like Transformers or Explainable AI. Oh, it runs on my laptop. Okay, the project is over.
Tom?
I just need to go see a company and put it on their server. Oh, in real life, there's a lot of non-artificial intelligence in a big pipeline. So what you're calling workflow, I call sensors, because in a lot of supply chain events, there is no people. There are no people. They're just sensors. Like you have a code bar or stuff. A bar.
We can't hear anymore, right?
About the size of a warehouse and all that. Then you have dynamic data, which is the events that are going on. And these events, you put them together in the theory of complexity, which is a field of science. It's not something you invent. It exists. It goes back. You can use, for example, graph theory. I use a lot of graph theory. And then you use chaos theory, which probably, I don't know most people don't understand. They think chaos theory is something about a butterfly that does something. Chaos theory is mathematics. It's something that was started developing in the end of the 19th century, and it is part of physics now. So it goes back to another subject. What you want to do when you do artificial intelligence, you have to know physics. You have to know something about physics too if you're going into the real world. And modern day physics involves everything. Involves analyzing the way animals walk, the way water goes in a river. So this is a science, a theory of complexity, spontaneous order and chaos. That's mathematics. That's something you learn if you go to a high-level mathematical class. So it's still back to mathematics, and then I just need in physics, and then you need some physics to calculate the orbits to see how things are going away and how you have to bring them back with actions. So that's different from artificial intelligence. So that's very interesting in your conversation, is you get nowhere in artificial intelligence without classical software and classical mathematics and physics. You're not going to use artificial intelligence for a differential equation to calculate the orbit of a rocket or to see how Perseverance was landing on Mars yesterday. You're using just standard physics and mathematics. There's no artificial intelligence in there, or very little, maybe some fixing the images, but it's, let's say it's minor, it's 5%.
Okay, so this is a bit overwhelming for me and some of our audience, I think. So we are asking people to know physics, good math, really good math. You mentioned math like 10 times so far. And we are talking about basics and not applications. In addition to artificial intelligence, in order to be able to apply good AI and like understand the fundamentals of AI. Is this true?
Yep.
And
even worse than what you're saying. It's worse.
Okay, and how worse? This is my first question. And if someone is feeling overwhelmed, like what could he do?
So yeah, so that's right. So it's even worse because if you speak about my last book on transformers, what are you going to do if you don't know linguistics? Well, how are you going to understand the commitment bank? How are you going to understand semantic role labeling? It's one of the main tasks is semantic role labeling. How many techie people know what semantics are? Did they study the structure of language? Do they know the structure of English, the structure of Arabic? Do they know the structure of Chinese? These are three very different linguistic structures. So if you're speaking about natural language processing only for English, oh, fine. But, you know, there are other people in the world. You know, there are a billion Chinese. There are people that only speak Arab. They only speak Russian. They don't want to speak English. So you need to know something about linguistics. For example, do you know that Chinese Asian languages are agglutinative? They don't have grammar like us. So if you're looking for semantic role labeling in Chinese, it won't work. You won't succeed at all. You can run it for 10 days if you want. It doesn't exist. If you're looking at, if you look like in Arab languages or Semitic languages, often the vowels are absent. The vowels are not important in Semitic languages than in Indo-European. So you need more. You need linguistics. You need really good math. You need really good physics. Really good history, cognitive science, neuroscience. So either you go and you study all that, okay, and you study a lot of that, which I did, honestly. I stopped studying when I was 36. I stopped my Sorbonne student card when I was 36, and I went to 3 Sorbonne universities. And I studied all of that because there was a president of the university who told me what I just told you. You're not going to go anywhere in the future if you don't have cross-disciplinary culture. So what do you do when you can't do that? Well, then you have to work in a team. So if you work in a team, you're bringing your cost up. Because in a world, in a company where you're entering a company, you say, well, I can do the job. Oh, fine. But I'll need him, him, and him. That's 4 people I have to hire? No, I'm going to go to Amazon Cloud, and we're going to use what AWS offers us, or we're going to use Microsoft Azure. We're going to use Google Cloud. We don't need you. In fact, we're not going to hire you. We're going to hire a consultant that will talk to Google and Microsoft team. We'll get a special annual support line, which I've already purchased. I did both. I did everything here to test it. So if you want to remain creative, well, then you're going to have to do this. If you don't want to be creative, you can just be a manager. And so you can just go up and say, I'm just the manager. I'm going to hire somebody. But if you want to be a real creative person, you're going to have education and culture that goes beyond just downloading stuff from GitHub and making it run.
So you are telling me that overwhelming is part of the job and it is healthy here.
Overwhelming is the only thing that's interesting in this job.
Okay.
Because people that are in artificial intelligence are people looking for adventure. They're looking for something new. So if there is nothing overwhelming and after 2 days, oh, okay, everything's fine, I have nothing to learn, you're bored. So overwhelming, the cutting edge, pioneer, that's what we want. We want friction, we want risk, we want to spend sleepless nights on things to find things. Or just trying to be a manager and just manage and let the other people run around. It's a choice of life. Be a learner or just be a doer. You can't, do what you want. I'm a learner.
Okay, Dennis, during your answer, you said a lot of time, decades, 19th century, something like that. For you, what's time mean?
Okay, so I thought about that because you gave MR and Marcia and all, you always get me thinking. So I'm just going to say it straight away, okay? Because I don't believe in time, okay? You have to believe in time to use it. It's a belief. It's like believing in something religious. No one can prove the existence of time. The only thing you can say is what time is it? It's because the sun rose, the sun even didn't rise. Just looking at the sun, the planets, and you're synchronizing. So you're saying, when I put my arm up, then we meet. That's time? So that's up. When it's here, we'll do that. And that's time? No. Or is it, what? I don't have time to do that, or this is not the time to do that, that's an event. So the word time has been used in so many contexts, I don't even know if there's a definition of time. So in modern science and physics, to go back to your question, Amar, and especially in quantum mechanics, which is one of my decade-old passions, decades. I mean, I was working on Schrödinger in the 1980s, okay? So time doesn't exist anymore at that level. We're speaking about entropy. Now, entropy is much more efficient than time. And if we translate it into everyday English, it's easier to say, how long, like you go to a garage and you buy a tire, you put tires on your car, and you say, how long will my tire last? You'll see the mechanic will say, what kind of question is that? It depends on many factors. Well, then tell me how many kilometers. That way I can divide the kilometers by my speed and I can get some time. Well, it depends. If you're driving in a city, you'll wear your tires out more than if you're driving on a highway. Oh, then I'm driving, yeah, but on that highway there's no traffic, because if there's a lot of traffic, there'll be. So there is no time. It's entropy. It's the time it takes to use something up, and you can't go back. It's not like the film The Tenet. There's this movie The Tenet where everything's going backwards. That doesn't exist. If I take my mouse here and I throw it and it breaks, there's no way you're going to go back. You're not going to go back in entropy. So the universe in modern physics is going towards entropy and is leaving time where it is, because what time are you talking about? Since we know since Henri Poincaré in the 19th century, Lorentz 19th century, and Einstein only modeled relativity was there in the 19th century, but people just think, that Einstein invented relativity. He didn't. He was part of a group of people like Lorentz and Poincaré. Ever since relativity exists, we know that there is no unique time. My time is not your time. It depends where even you are on Earth. Maybe you're going faster or slower. If you're in space, it's a different time. So entropy is a more interesting factor. So I believe a lot of entropy, and you have, like, if you go to traditional Chad, you go to Chad or Congo. Let's say you go to Congo in Africa, and you go into a traditional village. They don't use time like we do. They use entropy. They're much more intelligent. We think we're smart, but they're smarter, because the person will say, oh, we'll do that this afternoon. What does that mean? Well, first I have to go get some water. So the person will go get the water, and if he said he'll be around 5 o'clock, because he's talking to a European, he might be there at 7. And people say, oh, they're always late. No, he's always on time, because he did entropy. He went to get the water. It took him time to get the water, and it took him time to get back, and put the water quietly where it's supposed to be, relax, and tell the person, now I'm ready to talk to you. And I worked a lot also in Arab countries, where a person says, I'll come to your house at 6 o'clock. And then with a group of consultants, and the people say, look, at 6 o'clock, and he's not here. See how they can't. And I say, you don't understand anything. You don't understand anything. He's finishing his work. Of course, you're the guy at 5 o'clock, he's running out of his office, even if the work is not finished. We see that in France. It's 35 hours, I'm gone. Well, you go to Morocco, and you see the guy, he's not stopping. You say, and you look at him, and then you talk to him, you say, no, I didn't finish my work. I'm finishing my work. It's not 5 o'clock, it's 7 o'clock. So entropy is much more interesting than what we call time, which is basically synchronization. Things that are useful, but it's just useful for productivity, but it's not useful in life.
So is it easy for you? Yeah.
Just because right now, if you are thinking about
definition of entropy, please.
Yes, maybe the same, but okay, let's go with that. Go.
Well, entropy is just the second law of thermodynamics. Going back to physics, I didn't invent anything. I didn't invent entropy. It's just that if you take, I don't have a cup of, let's say I have a cup of tea here. It's in my book. You have it in the second edition of Artificial Intelligence. I explain this. Okay, you have this little cup, and in your cup. Now that's very interesting, Omar, because people are speaking in artificial intelligence every day. Cross entropy, entropy, cross entropy. They don't know what it is. They just downloaded something and they're running it. They don't even. So they're using something. So you take this cup of tea, and you say this cup of tea is hot. Okay. And then you put it down, and we're talking. Then you pick it up. Hey, my cup of tea is not as hot as it was before. So now I want you to tell me which molecule in that cup of tea was slowing down. You'll never find out. It would take you centuries to figure to analyze every single molecule in that cup of tea with something that could capture it, but that doesn't even exist. So that's where they started in the 19th century. Boltzmann, you've seen restricted Boltzmann machines. Well, Boltzmann invented entropy. S equals K times log the number of microstates. So people are using restricted Boltzmann machines, but they don't know what Boltzmann is. You have the big Hinton equation. They don't even know what it represents. So what it means here is I have these molecules that are warm in here, and they're together. They're in these little microstates. They're happy. They're happy together. You know, like little.
Warm and happy.
They're happy in their little cup and they're warm. But then there's this big bad world around, which is the cup, which might be cooler. In Asia, that's why they heat the cup up before they put the tea in it. Okay, so they're smarter than us in our cafes. And then you have it's cold outside. So now these little groups, they're in tension here, and they begin, to separate. They cool off, and the heat goes out of the cup, and you see the steam going up. And in fact, entropy increases. Everybody thinks, but entropy is increasing. You have all these, now instead of having maybe a million microstates in your cup, you have millions and millions of little molecules flying around all over the place. So as time
the number of microscopic configuration is increasing then.
Entropy always increases. That's what people, and then people are looking at, their cross-entropy thing, it's decreasing. That's gradient descent. That's it. So you're telling me that entropy is decreasing. Yeah, look, it's going down. But they don't understand anything about artificial intelligence. Because we first put random, you have all this in my artificial intelligence second example. You randomize your weights in the deep learning network, right? You go into your convolution network and you're so happy, you randomize it. And then you look at cross entropy and say, entropy is coming down, it's gradient descent. No, entropy is going up. Because all these random numbers were happy. They were like your molecules in a cup. You're the one that created that system. You were the god of the system. You told them that's the way your weights are supposed to be. So now they're all together here. And then you keep hitting them with your learning gradient, bing, bing. And they say, why is he hitting me? He's the one that told me to be like that.
Random,
And then they're changing. Instead of being together, they're constantly, you're increasing entropy. And all you're doing in cross entropy is making sure that the entropy of your training set fits the entropy of your learning data
That's why
set.
it's
That's
a
all.
cross entropy. It's not entropy.
It's cross entropy, but it's not gradient descent is not diminishing entropy. It's making sure they agree. That's all. So when your little cup of tea is cold, well, then it fits with the atmosphere that it's around it. Like when people open a bottle of wine and they say it has to be at room temperature, you're just making the entropy homogeneous, but it doesn't mean it doesn't.
The cross entropy will be very small because it is now homogeneous, but the entropy would be very big because there's a big difference between the old and the new state.
All the energy you're putting into changing the weights is the universe.
Okay.
It's the universe breaking apart. So you're breaking the whole system again apart.
Just for that time.
Entropy, it's huge, huge now. You've run billions of stuff. You made a whole, I would call a whole mess of it because it's long. Look at that, all these billions of parameters, like in the people admire GPT-3 because there are billions of parameters in this transformer neural language, in this neural network. And in chapter 6 of my book, there's this guy called Tom Schick that invented another method. He says, well, strangely enough, I beat GPT-3 on the ranking board, on the SuperBlue ranking board. At one time, he was number 12, and Microsoft was number 11. And he's just a student, a PhD student in Germany, okay? But he says, I don't have that money to buy a $10 million supercomputer. So I'm not going to run this entropy and make billions of microstates. I'm going to go to the data set, and I'm going to make smarter data sets so I can run it on a little laptop. And then I'll just see what it does. And he beat the GPT-3 model on the SuperBlue leaderboard. So now on internet, you have everyone speaking about transformers and GPT-3 and no. Sometimes intelligent people, like people in Congo or never, find better ways of doing things.
Just I want right now for our time and because this is would be merged with tomorrow event. So I want just to summarize what we speak about right now. Because we jumped from one idea to another, together right now we have this current situation of AI, current revolution of AI. Just if you give us, to close with this, if you give us a small historical view about where it started and how it's developed and how many ideas come together until we reach today. But please, it has to be quickly.
Okay, so quickly. Okay, so artificial intelligence is just a very tiny branch of automation. It's a very tiny branch, okay? You can go back to water mills. You can go back to windmills. You can go back to the first textile machines. You can go back to the first locomotives. You can go back to... So automation has been here. And then this big thing happened in the 20th century called a car. And when the car got there, everyone that was riding a horse or working for horses or selling saddles or selling whips out of business. So the cars came along, and with the cars came this crazy little thing called a tractor. And a tractor kicked all the people off the fields. Okay, so when you speak about artificial intelligence, think of automation. And one of my favorite examples is an ATM machine. Like young people go and they see this ATM machine. What is an ATM machine? It's an automatic teller. That's the name, a teller. And a teller is a person. It was a real lady. When I was young, it was a real lady and it was a real man. And you didn't have these machines. There were hundreds of thousands of jobs around the world. So then we replaced them with a machine. But then the data has increased. So at one point we needed to find a way to manage this data. So we invented SQL, right? Query language. which is used much more than artificial intelligence. And then we used pocket calculators that we transposed into computers. So now we have these astrophysic things where we send rockets and everything. There's no artificial intelligence in there, right? So then there's one or two branches that are interesting for artificial intelligence. It's natural language processing, like in my book on transformers. There's computer vision, voice recognition, but there's not that many things. That's what you have to realize. So people are blowing up this Terminator vision of the world where artificial intelligence will dominate us and we will have to go live on Mars. I'm not going to even say the names of people that say stupidity, because no one can live on Mars for the moment, because Mars has no iron core. So since Mars has no iron core, it doesn't have electromagnetic field. Since it has that field, you have no atmosphere. Since it has no atmosphere, you have earthquakes and stuff going all day long. So what people don't tell you is you're going to have to make the stations in cracks. So if you take this insane image of artificial intelligence taking over what? A differential equation calculating the resistance of a metal in a building. Okay, so artificial intelligence is just a new windmill. It's just a new windmill. It's a very powerful one for natural language, like in my last book, or computer vision, or it's very interesting. Okay, so but it's just a branch of automation, and I would say it's 1% of the automation, but it's fascinating. So why are we talking about it, to answer your question? Why are we even talking? Because it hurts our ego. We don't like it. We thought we were more intelligent. A windmill, how stupid that windmill is turning around in the wind. It is dumb. We are, these big gorillas. But then you have these algorithms on the internet with natural language processing that can do better than us on the leaderboards. Our ego is hurt. So now we have to imagine that it's bigger than it is. Or when we beat, like chess engines. There's not a single world champion that can beat a chess engine. It doesn't exist. But there's practically no artificial intelligence in a chess engine. If you look for it, maybe this. It's just a simple algorithm that's evaluating. It's in my book too, in chapter 3 of artificial intelligence by example. I just showed that if you're a chess player, you have at least 30 parameters to analyze every time. So just to sum it up, Dave, artificial intelligence is just taking all the math that was done maybe up to 1950, because there's been no mathematical innovation in artificial intelligence since Alan Turing in 1950, putting it into nice computers and doing other kinds of automation that are very easy to do. Computer vision, natural language, all these are very easy. But we're so surprised because it hurts our ego. So I think that our AI is just an ego trip. It's just hurting us so bad to see that this dumb laptop can be better than me in things that I thought that only humans can do. So what? I mean, if you have problems, go to church, go to the mosque, go to the synagogue, go look at something, bigger than you that you'll never understand. But these are very simple things. Artificial is very simple. Artificial intelligence, AI is simple. It's basic math put in a big computer,
Okay, so I have one small question here. Like, I've been considering myself to get the artificial intelligence by example book, but could you tell me more about what's the purpose that makes someone go there? Like, why would I get it?
Yeah,
it's like the description is acquire advanced AI, machine learning, and deep learning design skills. What do you mean by design skills here?
Yeah, so that's what I say to anybody that talks to me around me. They say, "Hey, Dennis, give me your book." I say, "Why do you want to read it? Weren't you happy before you knew me? Why would you want to read the book?" So I do have a few people in the computer science, and they say, "Yeah, but isn't there your philosophy of implementation in there?" Because if you look at what I just said, AI is a tool. Now, what do you do with it? In artificial intelligence, by example, it's just not Python example. It's how to implement it in a warehouse. How do you implement it for transportation? How do you implement it in an intelligent chatbot? How do you when I had this idea with Tushar Gupta, I wanted to put my life experience of implementing in corporations and just translate it into recent Python. Let's say that I took my life experience and just translated it into Python and math and the subject matter expertise and put it in a book. So it's not just a book about algorithms. It's just in between the lines and the paragraphs. Everything I just said is in there. Somewhere in the chapter, in one of the chapters, I say there's nothing new in here, guys. So what's new? So let's find out what's new. So I think that it gives you insight. That's why Peck put it in an insight. It gives you insight. If you just look at blogs and papers, you'll get no insight. If you take artificial intelligence, by example, you get insight. You also have explainable AI, you get insight. Transformers, you get insight. I always like to give insight, just like in this conversation. I can't help myself because since it's very easy to learn these algorithms, it's just basic math and basic Python and everything's ready to use. What's left? Insight, vision. That's what's going to make you last 30 years in the business. It's vision. It's not learning that, this algorithm does that. Vision.
Ammar, thank you. Dennis, certainly thank you. Ammar, thank you for sharing this with me. I have to stop here because we have to consider the time for other guests tomorrow. Thank you, Dennis. And right now I will stop the record.
Okay.
So I hope everyone enjoyed this.
Yeah.
Okay.
Oh, bye, Dennis.
I did.
Yeah, it was amazing. It was
Tom,
good.
It's actually weird. It's actually weird for me because I was there and now while I'm listening again, it's like I'm discovering new things. That's weird.
Something you missed.
In time, in time. Going back in time, you are discovering new things. So time exists, really. Time exists. And I do sympathize with Dennis, but I wish, he's in a place where time doesn't exist, which is a beautiful place. But many things are simplified then, for sure. Tom.
I used to. These are great philosophical points. I really enjoyed listening to. Yeah, but I enjoy more than philosophical. But we Marcin, as you know, we apply philosophy to the physical world and now to the data world, and those two worlds are a bit different, but not separated from one another. But I remember arguing with my wife when we were younger about why do you have to have a schedule? Just have it event driven. And yet in our country, if you don't operate by a schedule, there's a bit of foolishness to that. But these are analogies, of course. I'd like to jump in with something though. I want to confess, when I started learning neural networks and objective functions, cost functions, I had no idea those objection functions were ground in information theory. We weren't really, that wasn't really stressed at the time. And then I was on a very high level technical interview and they were challenging me on information theory. And I confess I was ignorant. I really hadn't studied it. And then I thought, if I want to look at these level of jobs, I'll go learn information theory. And what was my biggest hurdle with it? Now, I'm not, Shannon is brilliant and I'm not trying to take anything away. But when we talk about entropy in the physical realm, it really comes down to quality of energy. And so lower entropy is higher quality of energy. Now this is Dr. Ives' mechanical engineer background talking. Now, let's go over to Tom Ives, data scientist. Now that I really deeply appreciate information theory and why it's important to the derivation of objective functions when we're training a machine, I look at what Shannon described, and he took the microscopic point of view, the concepts of entropy, and applied them very well. But it's actually backwards. The quality of our information transmission is higher entropy. So the quality of energy and the quality of information in the entropy concept sense is reversed. And so for engineers that are really into understanding the physics of entropy, I would just caution them, when you come over the information realm, you're going to have to flip your thinking about quality. And that hung me up once I decided, okay, I'm going to study information theory. And I'm not embarrassed to say, one of the better sources to just get the concepts of the history of information theory is Khan Academy. I'm a big fan of Khan Academy.
Okay, just since you speak about it, Tom, let's see, give us a small brief about history of information theory. When it's appeared and how it's reflected to our field. I think you explain it, so this part, but when it's appeared and why it's important for us.
So this is a great question. When Shannon came on the scene, he's working for Bell Labs in the late 40s, and he's realizing, okay, if I want to improve this signal, it's going to be very expensive to improving the physics of the systems to get rid of this noise and all that. But then he began to consider, is there a way for me to get rid of it mathematically? That was the brilliance. And really, I would say that perhaps was the beginning of our AI age, where people were beginning to think, I've got data here, it's not clean. How can I get a stronger reaction from it? How can I increase the amount of surprise I should have from that data? And to me, that's the brilliance that Shannon brought to us, is to say, don't always focus on improving the physical system. There are ways to improve the differentiation in the information that's got noise in it. That was the key.
Martin, my question to you, Martin, is like the following. Now, this brilliance comes from Shannon. How it's interact or how it's conflict, I don't know, you are going to tell us, with the brilliance comes from Lotfi Zada about fuzzy logic and fuzzy control.
Well, yeah, fuzzy logic obviously is a new concept, and it basically undermines everything that Dennis has just said. Some of the things that Tom just said, reverses the reverse equation and adds dimensionality. So really, it does impose a lot of questions to the user. The user is empowered to observe the membership functions and impose them on the system. And this is very novel. In statistics, there's continuity. Here, one can observe a system that is basically being tested, for information gain, but there is no huge, I would say, pressure on the data. The data is kind of obsolete here. It's kind of, you are conducting in an experiment and setting your own membership functions, your own probability distributions within that experiment, even a neural network. A good example of that is ANFIS, which is a artificial neural inference system, which is obviously used in a very complex environment. So really, the fuzzy logic weights in a neural network are adaptive enough and streamed online to actually learn and make decisions. So it's really a much more efficient way of capturing really one step ahead the information gain, that is the predictive ability of that model to interact within many uncertain points in the future by pointing to a grid and constrained optimized solutions. Yeah.
Marcin, this is like actually really interesting, but like, would you give us like a clear example of how fuzzy logic is affecting AI? Let's say like, where is it like actually implemented? A cool example, please.
Yeah, I mean, obviously, fuzzy logic does not rely on a massive scale of probability distributions, and obviously, there's no statistical significance that imposed. So really, you can use fuzzy logic in a neural network to inference tuning of hyperparameters, which are very, very complex and really are unknown to the user. So really, what Tom was talking about, you are almost blind. What do you do when you are blind and you cannot see what your information gain is? And this is really how many practitioners at the moment are using AI, by trial and error. And here, fuzzy logic on an ANFIS can give you an inference point or many different points where you can reduce certain outcomes and obviously impose optimization. And with genetic algorithms, that works very well. So really, you're taking the end solution and rewinding it backwards and really imposing your set of optimized parameters to reduce error. And this is a great novel idea where a lot of basically even control systems for rockets, for us, NASA is really conducted. So it's very quick. It's obviously set to many assumptions, but really in static kind of image recognition, convolution neural networks, it can work very, very well, really, by reverse engineering the problem. Yeah. So there's great promise. Obviously, it's a great art as well to use. Obviously, experience. Yeah, an ANFIS system builds on a base of knowledge, which is obviously based on the inference rules that are imposed on the system, or environment reflection on the system. And this is really crucial. One has to have expert knowledge of that domain in order to make very accurate predictions. But in terms of reverse engineering, it almost sets the blind off the tuning of hyperparameters, which obviously are constrained examples of nonlinearity and several different optimized points on a huge scale. So it's much more efficient in that way. Yeah.
Martin, I want to. Yeah. No. This is first of all, I just want to tell the audience, I feel like one of the luckiest guys on the planet to get to talk to Marcin and Dennis, even outside of this time. Marcin, I have just a sincere question for you.
Sure.
As I was thinking back in grad school when I was first introduced to expert systems and the motivation for us to learn them, that, hey, we're not going to be able to use classic control system design techniques to solve everything. It just gets too, the amount of effort you have to employ to use classical methods to solve some problems just does not have the return once we keep increasing the complexity. And to me, that was the motivation to learn expert systems. And then when I realized that their close relation to fuzzy sets and fuzzy logic, but as I was listening to you, I was thinking, yeah, but how do we discover the best distribution of these fuzzy sets? And it occurred to me, oh, this is yet another motivation for reinforced learning. Would you agree?
Yeah.
Okay.
Exactly. This is exactly one of your greatest insights to really shine the light in the right direction. Reinforcement learning is really the grid that fuzzy logic works on. It has to work on a closed loop information gain between two different discrete time points in order for it to learn. The information gain is, how you would say, encapsulated in the architecture. So rightly so, there are many more interesting, obviously, ways, as you said, looking at open loop solutions based on probability, but this is actually already kind of imposed. And that was, I was thinking, the genius of the man who invented this, because he really did make it, the application of fuzzy logic is the holy grail, really, in AI complex systems, because the information is processed pretty quickly and almost real time, which adds adds that insight into the whole predictive ability to maximize that information gain. Yeah.
You know,
So,
this actually reinforces something Dennis was saying earlier. Think about how we got to reinforced learning. It didn't happen from a physicist or a mathematician or an engineer. It was brought to the forefront of our thinking by a psychologist. And this reinforces what Dennis was getting at. We need to be discussing across domains, integrating domain knowledge to take our thinking to the next level. Right now, I'm thinking if you put 100 of the top RL experts in the room, they would bemoan how hard it is to get the more advanced RL systems to solve. I'm wondering what domain insights we need to bring in to take RL solutions to the next level. And his point about, I don't think Dennis meant any insults towards doers. We need doers. But then there are those people that they do things. They're the people that would have gone on the Antarctic expeditions. They're the people that would climb Mount Everest. Then there's the intellectual climbers that are thinking, what's the hard thing to do? And there's still problems. Like, how do we go beyond transformers? How do we take RL solutions to the next level? There's so many problems still to solve.
Just to add to that, I think the next step really, as you rightly said, would to, this is, in my opinion, what AI is in the future going to look like. It's going to be based on intelligent agents, which are all working in a collusive fashion, learning from each other and from the environment. So there's going to be like a graph structure where you have several different agents working with themselves, learning, adapting, changing, obviously, even online, changing the structure of a learning curve, to adapt to the environment, to adapt to new objectives or rewards, with obviously a high degree of decentralized coordination, but still collusion. And intelligent agents really are the future, in my opinion, because they learn very quickly, they learn from each other, and the information gain is beyond the scope of any transformer they've encountered, really, because they're so flexible and they've got that closed information loop running all the time.
Sorry for interruption. First, both of you, Tom and Marcin, you got all my question. Well, I have nothing to ask right now during your discussion.
Exactly.
I have more to ask, though, actually.
But I want to ask Marcin about something. Here, when we are talking about, now, what is the difference between human reaction to the world, maybe one of the differences, and about, for example, the deep learning? Deep learning is trying to get from the data, let's say, the insights. Now, when we are talking about let's say, artificial agents or intelligent agents, we are depending on the environment. That means we don't have facts to depend on. We don't have data to depend on. We are depending on rewards according to your scenario. Now, here, I'm always, where we are able to use this, there is a lot of places, but where it has its limits, because my rewards might be negative, and this negativity might affect in a bad way. Always my example, it's from my let's say, my previous job about the healthcare. This intelligent agent, is it possible for the current scenario or for the current imagination that we are building right now? Is it possible to use it and trust it?
I think it is possible, but there's a high degree of risk involved, really. And here the problem is that, as with humans, there could be a wrong decision that could be made, a very unpredictable chain of events, which is completely unforeseen. And really, this is, this is something that artificial intelligence lacks. It can adapt, but it has a time lag. And if that time lag is quick enough to be so reactive that it can solve a problem in that instance, then obviously that is a success. It's either, you know, maximizing or minimizing risk, or maximizing obviously the I would say any kind of, you know, genetic algorithm deduction of what's going on, or in healthcare or otherwise. But you know, humans are also, you know, they get things wrong, and here I think the margin of error comes into what is the acceptable. I think Dennis mentioned it the other day. What is the acceptable margin of error that one has to obviously accept for the machine, for the artificial intelligence to do its work or not to be stopped? With deep learning, in my opinion, yeah, there's two ways of looking at it. Maybe the solution is more optimized, but then again, time is of the essence. So really, deep learning is like photographic memory. It's like a snapshot. You take a photographic memory, and then you add things together, and you have some kind of prescription of what you think one should do. And maybe this is the better way to approach healthcare. You know, the agents in many ways are, I would say, you know, they can interact, but really they can never replace a better diagnostic, which is based on all the information. And certainly accuracy of deep learning is much higher than agents, you know, working together. But and the reward function changes, then there is a high that it cannot cope with, and that is obviously the loose end here, and an excellent deduction here that you know, deep learning has many positive, you know, positive sides. Like Dennis obviously mentioned this with transformers and NLP, that obviously once the model is trained on a data set, which is obviously, you know, not is pretty large and obviously quite robust, then there's no need for reinforcement learning. You know, you only have gated kind of approaches to self-attention, which kind of adds to
I think we lose the mic from Marcin. Marcin,
Yeah.
I think your mic is
We can't hear you.
until
Last
now.
10 seconds.
Until now, yes. Tom, I think until Marcin back to us. Tom, you can
you
tell
give us like
something.
an illustration about what Marcin was talking about?
I want to make sure that I got the context of the question. Was this, guys, was the question about how deep learning can answer some questions, or was it more about how we would use it in decision making?
No, in fact, yes, we are talking about the decision making here.
Okay,
No.
that's what I thought. I have what I think would be a helpful illustration, but I'm very eager for Marcin to either agree or disagree. But to me, this is the way I see the current picture, and it's related strongly to my current work. Imagine there's a committee that has to make decisions, and it's a committee of intelligences, but they're not all human. And so some of the committee members, it's not just a language difference, it's a thinking difference. So I'm a big proponent of seeing our business organizational counterparts that think more linear than us as very brilliant people. We bring nonlinear thinking to the table. We're like Martians to them. And so when the data scientist comes into the room, hopefully the data scientist is bringing with him or her another intelligence that has spoken on this point by analyzing the data. Now, of course, those AIs, those math machines, those solutions are created by humans. But the point being, I think this gets to where to connect that brilliance and to make better decisions that include AI. And guys, you know, I was slow to come to the camp on this. That's why we need explainable AI to link that awesome nonlinear thinking to that awesome linear thinking and help it kind of go meet a higher level thinking altogether. But it's going to take effort and patience to get there. And I'm just trying to illustrate what I heard Marcin saying. I think that's what we're both trying to say.
I just want to summarize. Sorry, Tom, for sure it was great. And Marcin, are you with us right now?
Can you hear me? Can you hear me now?
Yes, we are able to hear you.
So these are all the points that I wanted to share. You got them all. And Tom, he has the wisdom. He has the XAI. And really, you need that. If you get carried away with the charm of AI, it's very easy to lose yourself. So Tom has hit the nail on the head. You need to stand your ground and see really where it can add rather than redraw the whole world. And I think this is exactly what one should consider in the future, especially with healthcare. Yeah.
You know, just a thought real quick I don't want the newer data scientists listening to this to think that we're all that. We're not. And we're struggling with all these concepts, by the way.
Struggling.
But let me point it out this way. If all we ever had to do was get some clean features and reduce them and scale them and run them through linear or logistic regression, you know, the AI would be the model weights and we would be done. But now we've introduced deep learning and reinforced learning and transformers, and we bring that to the committee room. We say, hey, this model told us this. Yeah, but how do I know I can trust that? Oh no, we're not in Kansas anymore. We are looking at something far more complicated than linear regression. Linear regression and logistic regression are now the bricks that we use in these giant, an analogy for business people that might be listening. Think of how big your financial spreadsheets can get.
Yeah.
Now, that's kind of what we're dealing with. We're trying to summarize it all and explain it, but this is new. All these transformers are 3 years old or 4 years old now. They're not very old. Reinforced learning's not very old. Yeah, we're still learning to explain it to our linear thinking friends, our doer friends, and it'd be wrong for us to look down on them. It's on us to bridge the gap.
Ammar, do you have any question right now?
I'm actually like overwhelmed again. Like I have lots of bullet points to see after the meeting. I have no questions because any question I'm gonna ask is gonna give me like something more to read. For now, I have like 10 tabs of Chrome to check when we finish.
Welcome to the
I
club.
have nothing left.
I will give you something more to read, Ammar. My question is for both Tom and Marcin. I will start with Marcin, and you can, for sure, the discussion goes. And this is the great about this session. We are in open discussion. Since we are speaking about the XAI, one of the methods related to the XAI is the SHAP, which is coming from Shapley values and the game theory. This is something I missed. I want to understand it, the game theory.
Well, I personally, I don't really, you know, I don't know. You know, you can explain many things, but if you can use Shapley to explain very complex AI with feature generation and statistics and so on, then you might as well use principal component analysis. It's very catchy, it's very nice, but it doesn't really add insight to the mechanics. It doesn't really break the black box into parts. You need to look at the mathematical derivation of the algorithms away maybe from statistics, just to reverse engineer everything and understand. That's my kind of take on that. So nice start, but really very preliminary, and I'm not quite sure if it's producible for reinforcement learning. I think if in convolution and NLP, it could work with multi-agents and very dynamic systems like fuzzy logic. Not sure if it's the best way to explain AI. Yeah. Okay. Tom?
So my answer will be much simpler. And I've got to, disavow I'm a student to XAI. I'm a new student to it. And I would say, hey, I have this smart friend named Dennis, and he wrote a book on explainable AI. You should go buy that book. It'll save you a lot of time learning explainable AI. But I do, if it's okay, I'd like to go back to some points that Dennis was making when he talked, if that's okay.
Yeah, sure.
Okay, great. If you look at the history of mankind using machines to make their work easier, it's a really good thought experiment. I'll just go back to someone who I think was a titan from the past, Archimedes. Boy, did he give us some cool stuff. And all these astronomers figuring out things about the stars and everything. But when I'm just a student of math and science history and engineering history, not an expert. But when I look back, I think, wow, Archimedes, he was a titan. And then we begin to see Michelangelo, et cetera. But then we really got into the industrial age where things started to be more magical. And we take it for granted now. But steam-powered devices, not just locomotives, but steam shovels to move earth. I mean, being able to move earth that rapidly. It was steam shovels that built the Panama Canal, or carved it, I should say. And then that was disrupted by hydraulics and internal combustion engines. And we see these advancements because, well, how can we do better? How can we do better? And everyone was relieved at each advancement. By the way, even with robotics, you go into manufacturing plants and you look at the reactions of the factory workers to robots and they're like, are you kidding? They took the monotony monkey off our backs. Now, I confess, I'm still trying to figure out what is it in our ego that threatens us when we see machines being able to process things we do mentally better than us. Now we've put the lever onto the mind. But I want to just ask everyone to do a thought experiment with me over the next year. Is it because of Hollywood? Have we just had these stories spun that make us think, oh, AIs are going to take over the world? Here's what I'm getting at. I'm more afraid of who becomes an expert at AI. Are they going to be someone that wants more than others? Or are they going to be someone that wants more together? In other words, they want to help all of mankind, not just themselves to get more than other men and women. So to me, I think the real danger is not the math machines we make, because let's remind each other, all AI problems are math problems. We're boiling down the language, whatever it is, to math. We're using computing systems. We're copying biological processes and stuff. But in the end, it's a math problem made capable by computers. But we are their gods. We are their creators. Yeah.
So we are asking, you are saying exactly that you are afraid of the people who are in charge of choosing the AI, the next AI application, and you are not afraid of the term of AI, like a robot who's gonna walk and do bad things, right?
Let me illustrate, Amar.
Yeah.
Let me illustrate. Yeah, that's exactly right. Let's say there's a party of individuals. We don't know anyone yet, but in the center of the room is an automatic weapon, a gun, an automatic gun. Now, I'm not really afraid of the gun being there. I'm afraid of the ignorance that I have of the person that goes to the room and picks that gun up. Are they good or evil? Now, take something more powerful than that gun, an artificial intelligence. Will that person that employs and creates that artificial intelligence be good or evil? We will only know
But
when we see them using it.
okay, so what's the difference here between artificial intelligence and, let's say, medical research? So both are things that are decided by people to go and dig deep into one thing over the other thing. For example, for the past year, we decided as humans and as leaders of medicine in the world to choose to go behind COVID and not go behind cancer this year. So what's the difference? Why are we talking about AI and not like medical application and medical research? Martian, do you have an answer?
Yeah, I mean, I think it's about responsibility. I think it's about AI ethics. And I think that's what Tom wanted to illustrate. You do need ethical people regulating AI. If you just give it to everybody, then yeah, it could obviously be used in a very powerful but a very negative way as well. And I think sometimes, obviously, a good illustration is even the production of COVID, Pfizer medicine, etc. It's not accessible to everybody. The pharmaceutical companies are using their bargaining position to, I would say, maximize the profits, right? So maybe you do need a higher inference tank to regulate it. And I think, if you give matches to a child, if the child could burn the house down, basically, And I think with AI, you do have to approach it with a lot of respect and respect for your ethics as well, because it can be used, obviously. Yeah.
Okay, so we are now discussing the possibility of regulating AI in order not to get where social media and big tech companies got, like not to be the full commander of everything without any regulation. But like, what's AI here? It's math and math applications. Like, will we put a restriction on using like, for example, the TensorFlow library because it's mainly used for AI? Or like, what's the point here? If I have a math equation and I want to apply it, I can apply it. No one could ask me not to.
Well, basically, to give you an illustration, if you have an algorithm now that is making money that is based on AI, you'll be just frozen. Your account will be frozen, either if you are in China, etc., and your AI will be just closed down very, very quickly. And I suppose, Bitcoin is making headway because it's very unregulated, right? Like AI, and I think it also creates opportunities but threats as well. And I think obviously accountability and ethics. So if everybody was as ethical as Tom, then that would be a great world. But obviously that's not the case. That's my point.
Here's the point I'm making. When you have something powerful in your hands, Amar, that was just first base. Let's worry about does this person that have the power in their hands, do they care about humanity? But that's not the end of the danger. They could care about humanity, and still some bias could creep into the data that could hurt our decisions with the model. In other words, we have to, it's an attitude of constant vigilance. But
Tom?
Yes.
A quick question. Do you think AI can be manipulated now and in the future by the people who design the algorithms and know the mathematics to make some gain for themselves on top of everybody else? Do you think it could happen, or is it happening now?
I don't know if it's happening now. One of my frustrations in life, both in our work, AI work, and in just everyday life, is we never know the whole story. We're like a stupid reinforced learning agent traveling around in our environment. Oh, Amar.
What's the point? We have all the tools. We have all the codes. Why shouldn't we know everything? Why should
Amar,
like the people who wrote the libraries, the people who wrote every library, every possible tool are giving everything in public. So why don't we just give some time to learn and go for the math, as Dennis was suggesting, and
So
like we will be fair. We will be playing fair with them.
I
Can
got
I
you.
speak, please?
Sure, go ahead.
Please. Sorry, Tom. Amar, first of all, right now maybe we are looking for kind of history of AI, and we think that everything is open. First of this is the first, but for example, explainable AI, which is right now it's look like a new branch, but it started from 90s. I mean, it's not a new thing. Maybe right now it's become on the production. There's a new framework that able to be used. Automated machine learning, AutoML, which is right now also there is from Google, some and from Amazon, from Azure. There is a new frameworks to use it, but also the start of it or the first trials, it was also from 1980s. And our friend Dennis Rossman also was working on something similar. So this is the first. We don't know everything. And nobody knows everything. This is a fact. We are keep learning. Now, as a community all together, yes, but how to find the community, all members of this community have the same target. But the real question here, I think, is are we really trusting only data to make a decision, either with any kind of algorithm? Is it enough only? For example, if you're a physician, for example, very expert one, the best one in the world, and he told me that your father will die after 2 days, I'm going to kill him immediately, or I will wait for these 2 days. Data is not everything. Now, what AI is promising us, that data will give you whatever you are able, or let's think like this, whatever you are able to get from data, we are giving to you. But the decision is not about data. Now, this is the difference here. Now, and this is where the ethics and everything was said by Martin and Dom, it's applied. It's after the data, after the insight of the data. This is how I see it.
If there's no information embedded in the data, you will get nothing, right? And this data will not mean anything.
Amar, I can't answer all questions, but here's where I was going to. And I'll give a recent illustration. Was our data complete and accurate to help us understand COVID? No.
I don't think so. I wish.
Aymar, look at the Bible. It's been translated hundreds and thousands of times. Do you not think the original Bible has been somehow a little bit lost in time? And it's the same thing here. You know, you cannot rely on time not to erode data. And there's even many experiments that even suggest 94% of the information is in the most recent data that you use. So it's almost illogical to know everything, because it kind of confuses you not to see what is happening now, or to see or interpret. You're almost overloaded with information. It's pure information, but it's just very chaotic, as Dennis said. To make sense of it, obviously it's nice to just throw away time, but you know, we as humans have a time limit, so therefore it's kind of superimposed on us to, you know, to maximize our life for learning. And I suppose that's one way of looking at it.
That's very well put. Amar, it's kind of like this. If you really step back and look at the big picture of what Shannon gave us, now we're having to operate with those principles at a much higher level. You and I know, Amar, we can't collect all the data from a population. When we can do that, that's a rare, highly controlled subset situation. But most of the time, the kind of data we're dealing with, it already has bias in it. Yeah, it's a sample. And so it definitely has bias. But we don't know the realms of the bias, so we're trying to deal with that as best we can. Now, when someone influences actively that data collection and dirties it and doesn't share all of it, and I'm trying not to imply any governments or business motives here, but we know they exist. Oh, it hurts everything. Now, but then I can imagine you're focused on those great areas of the medical realm like cancer. Okay, yeah. You know what? Everybody wants the data to be accurate for cancer because you're dealing with ethical researchers that have a passion to get accurate data. There's this human element. And it's not just, oh, what hands is the AI or what human heart created the AI? It's not just that question. It's what unintended consequences are going to happen due to all sorts of other things. And that's all I meant by, I feel like a baby too. Why can't I get all the data? Why can't it be clean? You know, and I'm an engineer. I work with clean data a lot, but it's still dirty. And, you know, and then you have to go investigate, why was that data dirty? Why did I get this outlier in the data? Oh, that's painstaking, because to just eliminate that outlier, that's kind of unethical. But to have to go get off your butt and go investigate why it's an outlier, that takes time and energy. I could go on and on.
Do you believe in synthetic data generated by AI as being some kind of proxy for what is not available? Or should that data be trusted? You know, artificially being generated by algorithms to, I don't know, make predictions, I suppose, of future trends where data is just
and augment the existing data, maybe.
Yeah, that's a great question. If you mean like SMOTE to balance a data set, for example, yeah, I mean,
that's scary, right?
It's a guesstimate, right? It's the best we can do to deal with the bias of the imbalance, and I think as long as we say, hey, I had to do this to do a better job on the predictions because of the weaknesses in the math, well, you know, at least we've owned it. You know, we've said, hey, this is just a weakness here, and it's what we have to do. But Amar, what I wanted to get at, we're just scratching a surface of a whole host of problems. Even when an ethical person that cares about humanity deeply is dealing with all this, it's a constant vigilance to say, what math can I apply that will deal with these unknown biases? It's going to be a challenge for a long time.
Okay, I have like one note to add over Martian's question. I just sent a link on the chat and the Zoom. It's a website called This Person Does Not Exist. It is it uses GANs to make a new face. Every time you refresh the page, you get a new one, and it is completely like legit. Like you cannot even say that this person isn't good. And if you are making a classification problem, of the faces, and you use those data, it will be legit. You will have an actual classifier. So why? That's an example of where you can trust them. You can trust the synthetic data.
Trust the synthetic data, you think? I would say that. Yeah, I mean, obviously there's a great case for that, but at the same time, it's an endless loop of GANs where it's almost very hard to reproduce something that is not related to the past or is not even kind of stochastic, right? So really, you are kind of using even fuzzy logic in GANs to make your own rules of who you want to, you know, I don't know, accept as for image recognition of kind of person that you're looking for. And I think that's rightly said, a good way to look at even fuzzy logic, where you're not sure what the answer is, but you could make sure that if it's a man or a woman, has a mustache, has brown, has black hair, and it kind of narrows your you know, and then the algorithm takes hold of of the synthetic data that is generated and picks it up. And so GANs, yeah, that I think that could work, but with limited, I would say, responsibility. Yeah, it's not really something that is like 100% or even 90%, in my opinion. Yeah.
Okay. Thank you, everyone. In fact, it was great discussion today. And if I open, even I prevent, again, yesterday I prevent myself from discussing with Dennis because of the time of the session. And right now also, I'm not discussing with Ammar and with Tom, with Marcin that much because of this. But it was really great session. Thank you, everyone. Thank you, Ammar, I'm happy to work on that again. Thank you, Tom, Marcin, thanks for this.
I'm also happy. Thanks everyone for joining us.
Thank you, guys. You made it work so well. And thank you again, Tom, Anmar. Great questions and great energy and thirst for knowledge of AI, which is great to be really interested in all the aspects in the future.
I like being friends with you, Marcin, because you're constantly thinking of things that I'm not. And then I know, oh, once I'm ready to think on that, I get to go talk to Marcin. It's awesome.
It never ends. It never ends, Tom. It kind of, it's addictive. It's very addictive because once you get to the mode of reinforcement learning, it opens so many domains, but it does impose a lot of questions. And I think this is really one aspect that I love the most, is the completely different field or interpretation of reinforcement learning, and really how it interacts with data and can solve some problems, I suppose, in the future. Yeah.
In fact, Ammar, just briefly, 2 last points. Currently, with current tools, and I hope we get even better ones, reinforcement learning is one of the hopeful areas to help us with that lack of the full story. That's what it's good at. But I want to reiterate something that Dennis said that is so brilliant. AI is a tiny branch of automation. And if we equate our AI age with the electrical age, which we're still in, by the way, it's the AI age is being helped by the electrical age. It wasn't all clean and safe and pretty in the beginning. When Edison and Westinghouse and Tesla were doing all their demonstrations back in the day, there was no nationwide grid in the US or other parts of the world. We're still at the early stages. We don't know what this is going to become. And but make no mistake, it is just a tiny branch of automation, like Dennis was emphasizing.
See you next month. Thank you, everyone.
See you next month. Ciao, ciao.
Thank you very much. Yeah.